Introducing Auto Layout. To make your label resize and change position relative to the screen, you can use Auto Layout. Auto Layout is a tool for defining relationships between views on the screen, such as these. The label should be 10 points from the left edge of the container. The label should be 10 points from the right edge of the container. The label should be vertically centered in the container, and the label should base its height on its content. If you think about those rules carefully, you'll realize that it doesn't matter how big the screen is. The constraints can still hold true. You don't need to define the width because it can be inferred by the left and right edge constraints. They say the label should be 10 points from the left and right of the container. The width will be the space in between. Note: in iOS, you usually don't refer to a size or coordinate on screen as a pixel, but instead as a point. A point is a device-independent unit of measurement that essentially translates to 1 by 1 pixels on a non-Retina device and 2 by 2 pixels on a Retina device. Be prepared to forget about talking in pixels. These constraints can define much more complex layouts, such as requiring the width of view X to be twice the width of view Y plus 30. You'll learn about some of the complexities of auto layout in Chapter 9, including how to create and manage constraints from your code. For now, you just need to understand how to create basic layouts in Interface Builder. Let's place several constraints on the label. 1. The label's left edge should be aligned with the left margin of the container. 2. The same should be true for the right edge and right margin. 3. The label should be centered vertically on the container. And 4. Its content should define its height. You can define these such that constraint 4 needn't be defined, because constraints 1 to 3 will define it for you. You do so by creating those constraints between the views in Interface Builder. Holding down Control and click drag from the first view to the second in the direction related to the constraint you want to make. For example, to define a constraint between a view and the left edge of the container, Control drag from the view to the left edge of the container. To vertically center, Control drag from the view to either side. To horizontally center, Control drag from the view either up or down. Before you start creating constraints, you should make sure you have approximately the right frame. You do this to remove the need to fine-tune the constraints afterward and then update the frame accordingly. A frame is a representation of the view's size and coordinates, which are set at runtime to match the requirements set by the constraints. Drag either side of the label to the margin of the container. You'll know you've reached the margin because a blue dashed alignment line will appear. Also, use the alignment guides to ensure that the label is centered on the screen. You're now ready to add constraints. Begin with the left constraint by control dragging from the label to the left side of the container. As you do, a solid blue line will appear between where you clicked and your pointer to show that you're creating a connection. Hover in the margin of the container on the left side. The entire container should be selected, and then you can let go of the mouse. When you let go of the mouse, a popover will appear with a list of options for the kind of connection you want to make. It uses some terminology you'll need to understand. Leading space. The left edge in left-to-right languages, or the right edge in right-to-left languages. Trailing space. Similar to leading space, but the opposite edge. Margin. Apple's recommended distance from the edges. Top-bottom layout guide. Similar to the margin, but also takes into consideration toolbars, tab bars, and navigation bars. Top or bottom space. The top and bottom edges, respectively. And aspect ratio. Handy for images or a view if the width should grow with the height, or vice versa. Keeps the aspect ratio you see in Interface Builder. To create the connection between the left edges of the label and the container, select Leading Space to Container Margin. This translates in a left-to-right language version of the application as the left edge of the label should be connected to the margin of the container. When you select this option, a bunch of orange lines appear, both dashed and solid. These lines help you visualize the current connections for the selected view, which, in this case, is the label. If they're orange, it means the system needs more information before it can properly decide on a view's frame at runtime. When they're blue, that means you've provided enough information to fulfill the view's X and Y position, as well as its size. Note: just because you have a non-ambiguous layout doesn't mean you've created the correct constraints. For some complicated layouts, you may have to try several different configurations, but the knowledge you gain in Chapter 9 will lessen the number of these erroneous cases. The solid lines are the constraints that are already working. You may be confused, though, because you defined only one constraint. Many of the different kinds of content views, such as labels, have what is called an intrinsic content size. Unless there's another constraint to override it, the intrinsic content size is used to define the width and height of the view. The two horizontal orange lines are the definition of the top and bottom of the label, and the dark orange horizontal line shows you the content's baseline. In the top left corner of the screen is a dashed orange square. If you look closely, you'll see that it's the size of the content Hello World in the label. This is a preview of what the auto layout system currently understands the layout to be. Everything that isn't set, remember the width and height are set by the intrinsic content size, will default to 0, which is why the preview is at the top of the screen. It's time to fix this ambiguous layout by defining the rest of the constraints. Begin by doing the same thing you did with the left constraint, but for the right side. After that, try dragging to the left or right onto the container. From the menu, select the Center Vertically in Container option. Tip: if you drag diagonally, you can usually access all the constraint options for the two directions you dragged. This means you don't need to drag in a perfectly straight line. The options only depend on the direction or directions the pointer moves from the starting point, and what view is under the pointer when you let go. Once you've done all that, all the lines will turn blue, meaning you have a non-ambiguous layout, one the system can find a frame for at runtime. You can see this in action by running your application again. Try rotating the simulator to see that the label stays centered no matter what. You could have let the width and height be defined using the intrinsic content size instead of creating constraints for the left and right margins. Then you would have constrained the label to sit horizontally centered in the container, drag up or down. This introduces the fact that you can create a layout using several different configurations of constraints and view attributes. Unfortunately, this also introduces the painful reality of creating layouts for multiple screens. Not only do you have to test the different screen sizes, but you also need to make sure you test a variety of content. Using the method you followed in this example, left, when there's a lot of content in the label and multi-line is enabled, the content wraps when it hits the width. In the other potential version, using two centering constraints, right, leads to an error. Because the content is defining the width and height, the label makes itself wide enough to fit the content, and so goes outside of the screen's bounds. This is just one example. We'll cover more in Chapter 9, but for now, you have a working Hello World application. Congratulations! iOS applications are inherently dynamic, though. Defining all the content in Interface Builder isn't helpful. You need to be able to update your views using code, more specifically, using Swift. Summary. By this time, you should realize the level of thought Apple puts into its tools. As you use Xcode 6, you'll increasingly recognize how polished it is. In this chapter, you've learned how to start a new project in Xcode 6. Now you can navigate the single window interface, and you've built your first adaptive layout using Interface Builder. These skills will form a foundation that you'll build on throughout the rest of this book. In the next chapter, you'll detour from building the example iOS applications in order to learn about Swift as a language. You'll begin using Swift to build small scripts and come to understand some of the language features Swift provides.